The last part of section 5.3, as well as section 5.6, deals with solving quadratic equations, which is the whole purpose of this unit. Just as we solved linear equations in Unit 2, we are now going to practice solving equations that are quadratic in nature in Unit 5. There are three ways to solve a quadratic equation. The first way, in which this video is going to talk about, is by graphing. The next video will talk about factoring, and when we get to section 5.6, you're going to learn and memorize the quadratic formula. Probably the most popular method would be the quadratic formula, and the factoring method is probably the second most popular, but it is very important to understand graphing and how it works and why. And so that's what we're going to talk about as we go through the 4 slides. I'm going to fast forward to the next one. Now, we're going to talk about the basics for solving a quadratic function. First of all, our function's in the form ax squared plus bx plus c. In order to solve any quadratic equation, y has to equal 0. That is a must. You must always make the equation equal to 0. So basically, that's like where the f of x is. F of x is the same as y. I got to put a 0 right there in order to solve whatever equation it is I'm trying to solve. Now, the next thing we need to be able to do is read the highest power. If I have a quadratic function, let's say f of x equals 2x squared plus 4x minus 8, and I need to solve that. You look at the highest power of x. The highest power tells you at most how many solutions there are to your problem. Very, very important. How many solutions to your problem? Make sure that you understand that. So, anytime we solve a quadratic function, the power is equal to 2. Therefore, you're going to have at most 2 solutions to your problem. So make sure that you copy that down. Now, why is that the case? As I just said, quadratics have at most 2 solutions. Well, there are 3 situations. The thing you must understand, which I'm going to talk about here in a second, the solutions are where the graph crosses the x-axis. So, the first case and most popular scenario is when you have a quadratic parabola that crosses the x-axis in 2 spots. The red dots are the solutions, and there are 2 of them. There's also the case where the vertex of the parabola, and I didn't quite get there, but the vertex touches the x-axis. If it just barely touches the x-axis, there is 1 solution. And there are a few cases where your parabola won't touch the x-axis at all. It'll look something like this. In that case, there are 0 solutions. So those are your 3 scenarios. The solutions are where the graph crosses the x-axis. Now some vocabulary for you. Sometimes they're called solutions. But we also know these points from Unit 2 are called x-intercepts. Since y equals 0, and you know that's how you find x-intercepts, y is 0, They are also called sometimes the zeros of the function. And last, sometimes your textbook will use the word roots. All those words mean the same thing. All four of those words are referring to these solutions. Wherever the graph touches the x-axis, those are called roots, zeros, x-intercepts, or the solutions to the problem. Memorize that vocabulary. All those words go together. Now, let's use information from prior slides and information from what I just shared with you to graph x squared plus 2x minus 3. First thing we need to find the line of symmetry. And if you remember, that's negative b over 2a. Well, the b value is 2, so I'll put that in for b. The a value is 1, so I'll take 2 times 1, which comes out to be negative 1. So my line of symmetry on my graph of my parabola is that green dotted line. Now, if you remember, that's the x-coordinate of the vertex. So I'm going to put negative 1 as my x-coordinate. Now I got to figure out y. Well, I'm going to take negative 1 and plug it in for x. And if I do that, I believe I come out with an answer of negative 4. So my vertex lies at the point negative 1, negative 4. I'm going to put a nice big green dot right there. Now, the y-intercept, that's the c value. So my y-intercept is at negative 3. So I'm going to put a dot right there at negative 3. And again, using my line of symmetry, I also know that there's another dot right there. We need 5 points to graph our quadratic function. So the last thing that I'm going to try is I'm going to try a number, let's say x is 1. Now if I make a t-table, if I put x is 1 into my equation, I get 1 squared plus 2 times 1 minus 3, which actually equals 0. So therefore, the point 1, 0 is on my parabola. And if I use my line of symmetry, that's 2 off the line. So I'm going to go 2 off the line over here. And I'm going to find out that my other point is negative 3, 0. And again, I apologize for my smart board. Hopefully that looks pretty accurate. And there's my graph of my parabola. But the directions said to solve. Solve means, what are the x-intercepts? Those are the solutions to the problem. Those are the solutions, and I'm going to erase this a little bit. Those are the solutions, as I told you. If I'm going to solve x squared plus 2x minus 3, and in order to solve it, it's got to equal 0, what does x have to be? Well, the answers are the x-intercepts. This answer, the x value is 1 and the y value is 0. And this one, the x value is negative 3 and the y value is 0. So my solutions to the problem are x equals 1 or x equals negative 3. And if you would plug those numbers in, you would find out your answer is 0. And that is how you solve a quadratic equation by graphing. Find the x-intercepts, and those are your solutions. If you have further questions, let's discuss it in class.